guys at home? Can I get a thumbs up that you hear me and see the board okay? Okay, so yesterday we were solving polynomial equations or functions by factoring these higher degree polynomial functions and equations. So guys, it's some pretty heavy duty solving. So I didn't make your homework yesterday due until tomorrow night. So you still have today and you have tomorrow. I'm going to go over 2 more examples with you just to make sure that we're all understanding the process and what our answers are going to look like and what we're going to write on Delta Math, okay? And then when we're finished, I'll let you guys start working on the homework. Tomorrow, though, I'm going to have to add to this. I'm going to have to show you another type of polynomial equation that we're going to be expected to factor and solve, okay? But today I'm going to concentrate on the ones that factored by grouping again, okay? All right, so I put the steps up top. Remember, if you're going to find the zeros or the roots or the x-intercepts, these are the steps we're going to follow. We're going to set the function equal to 0. We're going to factor it. We're going to look for GCFs first. Then we're going to set each factor equal to 0 and solve. I just want to remind you, though, when you find these answers, they are known as the roots or the zeros of this equation, right? These are the numbers that are going to make the equation equal 0. You can get real number answers, but you can also get imaginary numbers as your answer. But when they ask for the x-intercepts, you can only say that the real number roots, zeros, or answers are the x-intercepts. So if we do get any imaginary numbers, guys, they're asking for the x-intercepts. We can't include that. If the problem had asked us to find the roots or find the zeros, then yes, we would be including the imaginary numbers as our answer. But because these problems are specifically asking you for the x-intercepts, we're not allowed to include any imaginary number answers in the end. All right, let's try one. I'm going to try to talk you through it somewhat, but then leave a little bit for you guys to do on your own as well. All right, so guys, the first example says, let me just try and get this board a little cleaner. All right, the first example says, just like yesterday, find the x-intercepts of the given polynomial function. Express your answer as a list of x values. So to find the x-intercepts, we want to find the roots and the zeros, right? So we're going to set the function equal to 0. All right, because they didn't give us a clue. I'm going to fall. I have to unplug this. Because they didn't give us a clue, they expect us to be able to factor this on our own. Guys, this is a degree 6. A degree 6 should have 6 roots or zeros at the end of this problem. However, if any of these 6 answers are imaginary numbers, we can't include them as our x-intercepts, all right? So we may not be writing 6 numbers as our final answer. All right, so if this is a degree 6, guys, I'm going to hope and pray for a GCF. So what does a 3x to the 6th, an x to the 5th, an 18x to the 4th, and a 6x to the 3rd have in common? Guys, they don't have a number in common, but they have a variable in common. How many x's do all of these terms at least have? They all have at least 3. So we can pull out a 1x to the 3rd. So I want everybody to do that. Show me what polynomial is left when you pull an x to the 3rd out of all that. I'll meet you at the end. Okay? You pull an x to the 3rd out, here's your new polynomial. What we always do after a GCF is we look at the new, this doesn't really work, but we look at the new polynomial and we try to factor it again. But guys, this isn't a normal 1, 2, 3-piece quadratic polynomial that we're used to factoring. This has 1, 2, 3, 4 pieces in it, and it's a degree 3. So the only thing we could try right now to factor this is to group it. So let's try to group it, guys. Everybody group the first 2 and the second 2. Now, when you go to group, please try your hardest to ignore that x to the 3rd right now. Just look at your new polynomial. So now you're going to find the GCF of these 2 pieces. What does a 3x to the 3rd and an x squared have in common? Everybody write it down. What's their GCF? You should have said x squared. So if you take an x squared out, show me what's left. What's left if you take an x squared out of these 2 pieces? You should have 3x minus 1, right? All right, now we go to the next group. When you go to the second group, you have to pull out their leading sign. So I have to pull out a negative. And now what does an 18x and a 6 have in common? What is their GCF? An 18x and a 6. Yeah, it is 6. So then what's left if you take out a 6 out of those two pieces? And technically you've taken out a negative 6. So negative 6 times what gets you back to that? X. Negative 6 times what gets you back to a positive 6? You need a minus 1. All right, it's still equals 0. So guys, remember, if factor by grouping works, you have to be left with this matching factor, this matching parenthesis, and we did. So the matching parenthesis is one of your factors, 3x minus 1. And then your second factor comes from, who did you factor out? I factored out an x squared and a minus 6. And then don't forget to pull your original GCF of x to the third down, because he's still one of your factors. And then we're still set equal to 0. So guys, you've done it. This original degree 6 polynomial factors to this. So once you're done your factoring, now you set your factors equal to 0 and solve. It is this part where you should technically get 6 answers. You should get 6 roots, 6 zeros, right? It's just not all of them might be able to go on as an x-intercept. If it's an imaginary, we can't say that's an x-intercept. All right, so guys, let's set each factor equal to 0 and solve. So first we're going to set x to the third equal to 0 and solve. Now, if this was an x squared, what would we have done? We would have square rooted both sides. Since this is an x to the third, what you technically should do, don't write this down, technically you should what we call third rooting. A third root would undo a power of 3, but I don't want you to do that. What I want you to do is, guys, think of this x to the third as x times x times x. Because that's what x to the third is. It's x times itself 3 times, right? So now you have x times x times x has to equal 0. Well, maybe this x was 0, so that's an answer. Maybe this x was 0, so that's an answer. Or maybe this x was 0. So guys, if you're solving a degree 3 equation, you technically should get 3 answers from that factor. And I do. It just, I get the same answer 3 times. So for anybody keeping track, making sure you have 6 answers, you just got 3 of them right here. But guys, it's really just x equals 0. That is the answer from that factor, but you did get it 3 times, okay? All right, let's go to the next factor. Set the next factor equal to 0. Got a little bit of work to do. Let's add the 1. And let's divide by 3. And you should get x equals 1/3. So right now you have 1, 2, 3, 4 answers out of the 6 that you're looking for. And then guys, we come to the last factor. Set x squared minus 6 equal to 0. And now guys, you're solving a degree 2 equation. You should get 2 answers from this. And 2 more answers would make a total of 6. All right, so let's add the 6 over. Let's get that x squared by itself. Now I can't do this x times x anymore because I could do it here because it was equal to 0. This isn't equal to 0, it's equal to 6 now. So like normal, how do we solve a quadratic? How do we unsquare something? Let's square root both sides. So a square root and a square will cancel, and x will be equal to, how many answers do I get when I take the square root of a square? It creates 2 versions of this, the positive and the negative. It could have been a plus or a minus number that I squared to get that. And guys, anybody know what the square root of 6 is? Is it a number that we can take a square root of and get a whole number back? No. Is it a square root where we could reduce it? Do any perfect squares divide evenly into 6? No. So guys, that's a reduced radical, so we leave it as the square root of 6. Now, delta math will let you leave it like this as the plus or minus, or they'll let you say x equals the positive square root of 6, and x equals the negative square root of 6. And now you can see your 2 separate answers. So guys, now you have 1, 2, 3, 4, 5, 6 zeros or roots to a degree 6 polynomial. So you got them all. You are here. All right? So now they asked for the x-intercepts. And they asked you to write them as a list of x values. So all you would do is go through. If you got any imaginary number answers, you just wouldn't list them over there. But guys, we didn't get any imaginary numbers. So all of these are good, guys, and all of these are going to be x-intercepts. So we're just going to list them. We're going to say 0. You only have to list it once. But guys, I checked. Delta math, if you did list 0, 0, 0, if you listed it 3 times, it doesn't mark you wrong. It does let you do it. But you don't have to list repeats. We got 1/3. And we got positive root 6. And if you notice on Delta Math, they give you a plus or minus sign, and they give you a square root button right under the answer box for you guys to click on. And then your other one is the negative square root of 6. So you could write your list like that. Or guys, if you don't want to write it like this, Delta Math lets you write this. You could do 0, 1/3, and then plus or minus root 6. Either way, it marks you correct. And those are your x-intercepts. And guys, at the end of the day, the square root of 6, it's like 2.4. It's just an ugly decimal, and we would literally cross over the x-axis at like 2.4 and negative 2.4. It's just an ugly decimal. So we leave it as the exact answer instead of the decimal. Okay, is everybody okay? How do we feel with that? Everybody's good? All right, let's try one more of these groupings. I'm going to try and really leave you on your own until the end of the problem. Guys at home, can I get a thumbs up? Are you okay? Great job, guys. Hang in there. All right, so guys, look at this one. Same directions. Find all the x-intercepts, right? So we got to set our function equal to 0 and solve. It's a degree 4. So at the end, a degree 4 polynomial should have 4 roots or zeros. But if any of those roots or zeros are imaginary, we can't call them an x-intercept. All right, guys, a degree 4, I'm hoping for a GCF. Let's look for it. X to the 4th, 4x to the 3rd, 7x squared, 28x. It looks like they have an x in common, and then because it leads with a negative, I am going to take a negative out. If it didn't have a GCF and it left with a negative, I could leave it, but I'm not because I'm taking something out anyway. So let's take out a negative x. So everybody get your new polynomial if you take a negative x out of all of these. It should take all the signs and make them the opposite. Everybody double check with me, make sure we have the same polynomial left. Okay, now our job is to take the new polynomial and try to factor it again. But guys, that ain't no quadratic that we're used to factoring. This has 1, 2, 3, 4 terms, and it's a degree 3. I would try to group that. So everybody group it. Group the first 2, group the second 2. And now you're looking for the first group's GCF, new polynomial, second group GCF, new polynomial. You guys try to factor this by grouping. Remember, you want that matching parenthesis, so don't force it, but use it to guide you. And try to really ignore that negative x hanging out in front right now. That's what I got for the first group. I took out an x squared, and that left me with an x minus 4. So I'm hoping for an x minus 4 in my next parenthesis, but I'm not going to force it, because sometimes grouping doesn't work. And I got to pull out the leading sign. And it worked, guys. Factor by grouping worked. So now what are your overall, in the end, factors? One of them is the one that matched. And the other one is who you pulled out, x squared plus 7. And then don't forget to pull that original GCF down. So there it is, guys. That's what the original polynomial factors to. So now our job is to set our factors equal to 0 and solve. All right, let's set this one equal to 0. technically all I have to do is divide this -1 away, and I still get 0. So there's one of the 4 roots or zeros or answers that I should get. All right, take your next factor, set it equal to 0, nice and easy. I get 4. So now I have 2 of my roots, my zeros, my answers. And because they are real numbers, I can definitely call them x-intercepts. All right. There it is. So now, guys, this leaves you with a quadratic equation. I should get 2 answers when I solve this equation. So I'm going to minus my 7 away to get x squared alone. All right, and then I'm going to get 0 minus 7 is -7. That is a red flag, but keep going. To solve, I'm going to square root both sides. I just took the square root of a negative number. I could never get a real number answer to that. So they cancel. I get x equals. When I take the square root of a square, it creates 2 answers, a positive or a negative. All right, guys, take us back to the imaginary numbers. The square root of -7, right? I got to simplify that. That's an imaginary answer. So the square root of -7, if you remember, the first thing we would do is split it into the square root of -1 times the square root of +7. And then we would say, well, who is the square root of -1? That's our imaginary number I. So that's going to be I. Then you would look at root 7. Can you take the square root of 7? No. Can you simplify the square root of 7? Do any perfect squares divide evenly into 7? No. So it would stay the square root of 7. So the square root of -7 is really I root 7. So it's plus or minus, cursor around the way, plus or minus I, the square root of 7. And now these are your 1, 2, 3, 4 roots or zeros to your degree 4 polynomial. But guys, they didn't ask for the roots of the zeros. They asked for the x-intercepts. The x-intercepts will only be any real number answers you got. So now when you go to make your list, your only x-intercepts are 0 and 4. Because those are the only real number answers you got. You cannot list an imaginary answer as an x-intercept. Now, I still like you guys to solve it because, guys, in the future, it might say, find the zeros. And then you are going to include this as an answer. So I still want you to be able to fully solve it. It's just because it asks for the x-intercepts, we're only keeping the real number answers. All right, how do you guys feel, okay? Everybody good at home? Thumbs up? Okay, so again, there is no new homework tonight. You're still working, and it looked like some of you did finish it, so awesome. You're still working on the homework that I posted yesterday. It was 10 questions on solving these higher degree polynomials. So guys, yesterday's homework, it only had quadratic ones to factor with GCFs, or it had these factor by grouping ones, but those are the only 2 types of problems on your homework. Tomorrow, I'm going to throw something a little new at you again, all right? All right, so let me just double check your attendance, and if you don't have any questions, you'll be good to go.